Hi everyone, I'm Dr. Thomas and today I'm going to walk you through the application of Laplace transformation in solving simultaneous ordinary differential equations. We can also solve partial differential equations, but here we are going to solve only ordinary differential equations. The theory of Laplace transformation, it is also referred as the operational calculus, has its interest in most of the mathematical background which are required for engineers, physicists, and all other scientists. This is mainly because it is a great tool which can be solved, which can be utilized to solve many problems in the science and engineering field. So let us talk about the Laplace transformation. And this is actually invented by the Pierre-Simon Laplace, who developed mathematics in the various fields of his interest, astronomy, physics, and statistics. He began his work in calculus, which led to the Laplace transformation. And in fact, he has done the Laplace and inverse Laplace transformation and application of Laplace transformation, etc. And he focused all these fields in celestial mechanics, mainly in black holes. Now today when you solve a simultaneous differential equation, we may have equations of this form which are given here. Say equation in terms of dx by dt and dy by dt, or even you can have the second order derivatives or third order derivatives with these constants a1, b1, c1, d1, etc. as absolute constants, and that t is independent variable. The main reason why we use t is here is mainly because of the time variable, which we always use in electrical currents and linear displacements, etc. So let us try to solve equations of this form. When we are trying to solve these equations, there are two things we should remember. One, we are going to make use of the Laplace transformation initially. Once when you use the Laplace transformation for both these equations, maybe these x of t's, y of t's, and its derivatives, second order, first order, all those things can be converted into a function of the form x of s or y of s. That is the transformed functions x of s or y of s. And then you are going to convert these transformed functions x of s and y of s into the inverse Laplace transformation to get the values of x of t and y of t. So it is a two-way process. The first process is by taking the Laplace transformation. The second one, you are trying to find the inverse Laplace transformation. So let us solve these simultaneous differential equations. Let me take the first one. So let us solve these equations dy by dt plus 2x equals e raised to t, and we also had dx by dt minus 2y equals 1 plus t. These are the two equations. So when you take equations on both sides of equation 1 and 2, you get these three equations. Or we can rewrite the equation as x of s, y of s, in terms of x of s and y of s. So these are the two equations what we got using the Laplace transformation. So now, right now, what we are going to do is we are going to take solve for x of s or y of s. Since these two are simultaneous equations, like as in ordinary algebra, you have x and y, you try to solve for x and y. So here we are trying to solve for x of s and y of s, the functions x of s and y of s. So when you solve those equations, you get x of s as this. And the same way you can find the value for y of s also. But here I have showed how to show the value for x of s alone here. And when I would like to find the Laplace inverse Laplace transformation, I have to split this using partial fractions because otherwise I cannot make use of the inverse Laplace transformation. So these results, what I have here, we have split that using partial fractions. We have combined this result, and that's what we have for x of s. Here we have to take the inverse Laplace transformation. When you take the inverse Laplace transformation, your x of s becomes x of t, and that's what we get. And the same way, you can solve for y of s, or maybe from the second equation itself, you can substitute the value for x of t, substitute one value and try to get the other value. That's what we have got. Either way, you can solve for x of t, y of t, then take the inverse Laplace transformation, or by substitution method, you can easily get the two results, x of t and y of t. So when you're trying to solve systems of equation, there are two steps. One, take the Laplace transformation and then take its inverse Laplace transformation. I have given some 4 questions for practice problems. You can try those problems. The answers are also given here. You can cross-check whether your answers are correct. And then maybe you can try these problems as an additional homework. Thank you. Thank you for being patient and watching this video.